Hello, so this is question 3 from the AP Calculus BC exam from 2017. And so the question says the function f is differentiable on the closed interval from -6 to 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. So part A asks us to find the values of f of -6 and f of 5. So to find f values, we know we're going to want to take the integral of f prime of x. To go from the derivative back to the original function, we're going to want to use the integral. So if we're trying to get f of -6, the only point we know of on f is f of -2. So we're going to have to use that point. So we're going to say f of -6 is equal to f of -2. And then we're going to do plus the integral from -2 to -6 of f prime x dx. And so since we are starting at the point of -2, we want to take the integral from -2 to -6 of f prime of x. But normally when we take integrals, we take it from the lower number to the higher number, but this integral is set up from a higher number to a lower number. So to fix this and to make a more logical sense, we can say that f of -6 is equal to f of -2 minus the integral from minus the integral from -6 to -2 of f prime of x dx. So this just makes it easier for us to see, because all we need to do now is take the integral starting at -6 to -2 instead of worrying about going backwards and flipping it, because we flipped it by switching it to a negative instead of a positive. So now what we have to do is just calculate the area from -6 to -2. So it's just a triangle with a base of 4 and a height of 2. So we're going to have an area of 4. So f of -6 is going to be equal to 7 minus 4, which is 3. So next, we're going to want to look at f of 5. So we're going to use our same method. So f of 5 is going to be equal to f of -2 plus the integral from -2 to 5 of f prime of x dx. And so this integral goes from a lower number to a higher number, so we don't need to worry about flipping a negative or anything like that. We can just take the area of the graph. So from -2 to 5, we're actually going to get this semicircle. So the area of a circle is pi r squared, so we can see that r is going to be equal to 2. So we get 4 pi, except it's just a semicircle, so our area is just going to be equal to 2 pi. And then the area of this triangle over here has got a base of 3 and a height of 2, so it's going to have an area of 3. So we're going to get 7, but this 2 pi, since it's a negative area, we're going to want to subtract 2 pi and add 3. So f of 5 is going to be equal to 10 minus 2 pi. And so those are our two answers for part A. So now we can move on to part B. So part B says, on what intervals is f increasing? Justify your answer. So to find out when f of increasing, all we need to look at is when f prime of x is positive, because when f prime of x is positive, it means that f is going to be increasing. So we need to justify our answer, so we need to write that out. So we're going to want to say something like f is increasing on the intervals from -2 is less than x is less than, -6 is less than x is less than -2, and 2 is less than x is less than 5. Because, and this is an important part, this is the justification part, so f is increasing on the intervals because f prime of x is positive. So without this justification, you might lose a point because it asks you to justify it. And so it's just, these are the intervals of these lines when f prime of x is positive. So now we can move on to part C. So part C says find the absolute minimum value of f on the closed interval -6 to 5. Justify your answer. And so if we're looking for an absolute minimum value, we want to look at where f prime of x is 0 because those are inflection points. But since it's asking us to find an absolute minimum, we also need to check out the endpoints because we need to make sure to check those points to see, because we don't know where the graph of x actually starts. So we're going to want to check out x equals -6, -2, 2, and 5, because those are our inflection points where f prime of x equals 0, and those are our endpoints where we don't know what's happening. And we need to check all of these. It's like a candidates test, so we can find out what the absolute minimum value is. And it's also asking us to give the absolute minimum value, so we just need to evaluate all of these x values. And doing this candidates test is kind of a justification for your answer because you're checking every single possible x value. So as long as we do that, then it justifies that we're getting the right one. So f of -6 we actually already found in part A, so we know that this is going to be equal to 3. F of -2 we know is equal to 7 because that's what it gives us in the question. F of 2 is the only one we haven't solved for, so we're going to need to solve that. So f of 2 is going to be equal to f of -2 plus the integral from -2 to 2 of f prime dx, which is going to be equal to 7 minus a 2 pi, because that's the area of our semicircle. 7 minus 2 pi. And then f of 5 is going to be equal to 10 minus 2 pi, which we also found in part A. So now, since we tested all of these values, we can justify what our minimum value is going to be. So if we look at all these values, we get 3, 7, 7 minus 2 pi, and 10 minus 2 pi. So you can rule out 7 and 10 minus 2 pi because those are obviously greater than the other two. And if you look at 2 pi is going to be somewhere around 6. So 7 minus 6 is going to give us a value somewhere around 1. So you can tell that that's clearly going to be less than 3. So our absolute minimum is going to occur at x equals 2. And it's asking us for the actual f value, so you have to state that f of 2 is going to equal 7 minus 2 pi. And so this test that we did is a justification, but if you look at the graph, you can also tell that it's going to be an absolute minimum at x equals 2 because the graph is, since f prime of x is negative, f is going to be decreasing. So we know that it decreases until that point and increases everywhere else, so we know that it's going to be an absolute minimum, and that's just another way to kind of logically justify it. But you want to make sure you check out the endpoints and the points where f prime of x equals 0. So now we can move on to part D. So part D says for each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. So we can look at the second derivative of f of x of f of -5 is just going to be equal to the slope of -5 on this graph f prime of x. So if we look at the point -5, it's going to be right here. And so we can see that this segment of the line is going to be, it's going to run 4 and rise 2, or it's going to be a negative slope, so it's going to be a -2/4 slope, which is just -1/2. So f double prime of -5 is going to be equal to -1/2 because we can just look at the slope of f prime of x. So we took the derivative of f prime of x at -5, and that equals -1/2. So f double prime of 3, if we go back up to a graph, you can see that at 3 there's a corner point. So there's one segment coming into it with a positive slope and one segment coming out of it with a negative slope. So it says in the question, find for each find the value or explain why it does not exist. So this is a point where the double prime does not exist, so our second derivative doesn't exist, and we would want to give a justification. So we could say something like the limit as x approaches 3 from the right, or from the right, does not equal the limit as x approaches 3 from the left. And these are both of f double prime. And so this is just saying that the slope as you come onto 3 from the right does not equal the slope as you come onto 3 from the left. That means there can be no slope at x equals 3. So f double prime of 3 does not exist. And that is the final part to question 3 of the 2017 AP Calculus BC exam.